Newton's Laws Demonstration by Matthew Baranio. Newton's first law. Newton's first law states that an object will maintain a constant velocity, zero or non-zero, unless acted upon by some outside net force. For example, a car that is at rest or a car that is moving at a constant velocity demonstrates this principle. Newton's second law. Newton's second law states that an object that is acted upon by some outside net force will accelerate. The acceleration will be directly proportional to the magnitude and the direction of that net force and inversely proportional to its mass. So basically, in other words, the net force is equal to the mass multiplied by the acceleration. For example, this person pushing a 40-kilogram ball with a force. Newton's third law. For every action force, there is a simultaneous reaction force equal in magnitude but opposite in direction. A good example of this is recoil when shooting a bullet from a gun. The bullet is shot forward and a force is being applied to the gun with equal force but opposite in direction. And this is the video demonstration using a 15-pound or 7-kilogram weight. So as you can see, at rest, the weight is at rest and will continue to stay at rest unless an outside force is applied due to the law of inertia, Newton's first law. Because of this law, the net force is currently at zero. In addition, the force of gravity is being applied onto the weight in a downward direction, while the normal force equal to the magnitude of the force of gravity is being applied to the weight in an upward direction due to Newton's third law. So the math for at rest, using F net is equal to ma for Newton's second law. Since the object is at rest, the acceleration is at zero. Therefore, using simple maths, F net is equal to 0. For Newton's third law, since the net force is 0, this means the sum of all forces is 0. This means that the normal force minus the force of gravity is 0, making the normal force equal to the force of gravity. So for picking up the weight is accelerating in an upward direction because of the force I'm applying using my arm. This shows Newton's second law. One thing to note is that it is accelerating upwards and has a net force in an upward direction. So the math for picking up this weight is that the sum of all the forces is going to be positive. It's going to be a positive value in an upward direction since the applied force is greater than the force of gravity, shown through the object being lifted off the ground.